Hey, good morning. Hope you had a good Thanksgiving break. It was nice to have that extra day off of last Wednesday, right before Thanksgiving. I hope you had some good turkey dinner and spent some time with your family and friends. Today, we're going to start a different way of solving systems of equations. Your homework on Tuesday of last week probably got a little challenging on a couple of those problems, especially if they were like counting by threes and you were trying to figure out where they crossed. I'm hoping that you used Desmos on graphing a couple of those problems. That is a good tool to have and use, but again, don't rely on Desmos to kind of give you all these answers, because even like today, you could use it by putting these equations into the Desmos program and find a solution, but that doesn't mean you know how to do it by substitution and showing your work. And so use it as a tool to help you, maybe to check your work and see if you got the same thing by using substitution. So there's three ways to solve systems of equations that we're going to learn this year, and this will be the second of them. And it requires a lot of manipulating the variables to one side or the other and collecting like terms and things like that. And so your math skills of doing one side to the other is very essential here. So do your warm-ups. As always, I have the warm-up on the next page. And so when you're done with the warm-ups, let's see how you did. Here's my answers and my work showing me getting my answers. So I hope you did okay. Number 3 and number 4 are very critical today. How do I get the x by itself? Or sometimes the y if I have two variables. I can choose. Today we're going to have two variables. Okay. All right. So kind of with the internet thing like this, when I was a kid and we wanted to go to a concert, we would have to go and wait in line. If we wanted, it was a real popular concert and we wanted good tickets, we'd have to spend the night out on the curb wherever they were selling the tickets so that we could be the first. But with the internet, it's kind of like the joke is, just wait until midnight and then you just wake up and go on your computer and buy your tickets. I'm hoping that concerts and things like that will come back soon so that we can start participating in those things. COVID kind of just really messed things up this year for us. A couple things on this page here I'd really like for you to highlight. This is how we're going to solve systems of equation by substitution. We're going to solve for one variable. So that's going to be our first thing. There's going to have two variables in our equation. So the first thing is we're going to take one of the equations. It doesn't matter which one. We're going to solve for one. And then we're going to get it, and we're going to substitute it into the other equation. And then we're going to solve for one of the other variable. Now, this is kind of important, too, that once we get like x equals 3, we want to substitute that value into an original equation. This is important. One of the original equations. It doesn't matter which one you substitute it in, but you always want to go back to the original one rather than the one where we started messing with the equation to get the variable by itself. And then the very last thing, some of you that are turning in your papers are not putting parentheses around your coordinates. It is a ordered pair, so when you write your answer, it goes in parentheses. Okay, this is a place on the graph where the two lines will cross. Okay, so about 6 of you just put in two numbers, 2, 3, and then even one of you wrote me a letter saying I forgot to put the parentheses around it. It's a coordinate. Write them as ordered pairs. Okay. All right. So don't worry about number C there. I have C twice on your study guide by accident, and that'll give us more room down below. So you can just cross off C right now. But as we look at these two problems, I see that the y is by itself over here on both of the equations. Oops, let me get rid of that. And so what I want to do in substitution is I want to take this amount now, this 2x, and I want to substitute it in for the y on the other equation. So now my equation is going to say 2x equals x plus 5. And now you'll see that I only have one variable, so we want to solve for that variable. So I got x equals 5. So I know the x part of my coordinate is going to be 5. Okay. Now, very important, like the directions on the up above where we highlighted, you need to substitute this 5 now into one of the equations. Doesn't matter if you put it in the first one or the second one. Okay, but you have to put it back into the original equations, one of the original. You're going to see here in a minute, we're going to start moving things around one. So it doesn't really matter. Sometimes one is easier than the other one, but I'm just going to substitute it into the first one. So I got 2 times 5, which y equals 10. So we could check it real quick here. 10 equals 2 times 5. 10 equals 10. So it works in the first equation. 10 equals 5 plus 5, and it works in the second equation. So we can check them. And today, it's kind of like up to you as we go along here. Quizzes and tests, I would for sure check them. Take the time to check them. Okay. I am 100% sure that my answer is 510. It works in both equations. Okay. So let's move on to the second one now. Now you see how this one up here, the x and the y is on the same side, but we have the y here by itself. So what I would suggest to do is take this whole amount in, substitute it into that first equation for the y. So now we have 2x. Instead of writing y, I want to say plus x, it's a positive x, minus 4 equals 5. All I did is put this whole amount in for the y up here. Okay, now this is a common mistake kids make. This x and this x are on the same side of the equal sign already, so I'm just combining like terms. So make sure you put the like terms together on the same side. I'm going to get my x by itself. So again, some kids are still struggling with this. How do I get the x by itself? It's a critical skill that we need to be able to do quickly. So far my x is a 3. Now we want to go back up and we want to plug it into one of the other equations. Probably that first or second one I want to plug it into. Y equals 3 minus 4, which y would equal a negative 1. Again, you could kind of check it mentally. If I put a 3 in for the x, 3 minus 4 is a minus 1. Yep, it works there. 3 times 2 is 6. 6 minus 1 is 5. 5 equals 5. So I'm, again, 100% sure. Mentally checking your math work. All right, we're going to go down to the bottom here where we have a little bit more room. As you can see, there's a lot of math involved here. Now, sometimes the x or the y isn't by itself. And so with one step, we could get it by itself. I could just minus 4 y's on this first one and get the x by itself. I could subtract an x. There's lots of ways we could solve this one. So let's just subtract an x from the bottom one here. All the ways would be okay. If I wanted to get the y by itself, like I'm doing here, or I could get the y over here and get the x by itself and then substitute it in for the x. Either way, there's like 3 different ways I see that we could do this problem. Okay, so when you do your try it on the next page here, your work might look similar to mine, but it might not, depending on which variable you got by itself. So I got this whole amount by itself. Now, this is also important. If I monkeyed with this one, so to speak, to get the y by itself, then I want to take this amount and I want to plug it into that equation up there. Okay, you have to plug it into the other equation. So now I want to have x equals, not equals, x plus 4. I want to have parentheses because this is now a group. And so I want to take 4 times that y right there. And I said the y down here was a minus x plus 3, and that equals 6. So now you have to go back to the distributive property. Well, I'll bring my x down. Minus 4x plus 12 equals 6. All right, take it from here now. Collect their like terms. These guys are on the same side of the equal sign. Got x equals 2. So the x part of my coordinate is a 2. Now, again, go back and just decide on which one would be. They're both about the same. So I want to do the second one. X, whoops, I said the x was a 2, didn't I? So I want to say 2 plus y equals 3. Get that 2 to the other side. I get a y equals 1. So a 2, 1 is where these two lines would cross. Okay? All right, you have a try it now, so give it a shot. Pause your video. You have two of them. One where kind of the y is already by itself, so it'd be smart to put this 2x plus 5 up there where that y is. And then over here, oh, I got an x by itself, so this one isn't going to be so bad. Take this whole amount, plug it in for the x on that equation. All right. Welcome back. Let's see how you did. For the first one, I got a negative 2, 1. And the second one, I hope you got a 0, 2. So there's all my work. All right. All right. So word problems, I think. Nope. We got distribution problem. Distributed property. All right. So now looking at my two equations, I'm planning ahead a little bit. That, if I try to get this y, I want to have a 9 divided by 5. That's going to be an ugly problem. But I do see that this x is almost by itself. I could easily just add a 4y to this one. And then I don't have any fractions in my equation. But I do have x equals 4y plus 11. I want to take this whole amount and I'm going to plug it in for the x on this equation. So let's do that. I don't know why today I'm going to keep writing equals. So I got 4y minus 5 times that whole group of 4y plus 11 equals 9. Let's go ahead and solve it. Let's see, 55 plus 9 is 64. Last step, let's divide by a negative 16, and I'm hoping 16 goes into 64 nicely. I know it's going to be a negative, positive divide by a negative. And it does, 4 times. So my y coordinate is a negative 4. Now make sure you put it, we solved for the y, so make sure you put it in the coordinate, part of the coordinate that's the y value. Now let's go back and plug it in. It looks like the second equation might be the easiest to plug it into. We said the y was a negative 4. Now we want to just get the x by itself. What's that, negative 5? I don't know why I put a box around it. So my coordinate is negative 5, negative 4. Substitution is really used often when our graph, we can't read it by, it's a decimal or something along those lines, our answer where the x and the y coordinate cross. If it's a decimal or the grid is too small for us to tell, they're counting by threes like you saw on Tuesday's paper. So you have a try it now. Do that, pause your video, and come on back. All right, so welcome back. Here's what I got. I got a negative 1, 6. I mentally checked it, and it worked. It's really easy on the first one, because negative 2 times negative 1 is positive 2, plus 6 is 8. And the second one, 3 times negative 1 would be a negative 3, and 6 times 2 is 12. Negative 3 and 12 would get me back down to positive 9. So get into that habit of checking your work mentally. okay, even though it doesn't say it. All right, here's our internet problem. This happens all the time. One company will have a setup fee that can cost of $30 a month, and the other one has no setup fee and costs $40 a month. And how many months will both providers be the same? As soon as they say the same, I'm thinking in my head, systems of equations. They also gave us a little extra part of writing our equations. They say let T represent the total amount paid and M be the number of months. So total paid is T. The word is equal. This one's kind of interesting because they want the setup fee, which is $50, plus cost per month. In plan option 1, we have $30 per month. So if I went for 2 months, I'd have $60. 3 months, $90. Option 2 is, so this is my cursive T, so I don't mess it up with a plus sign. So cursive T works well. Another provider has 0 setup fee, so I'm not even going to write 0 there. And they have a $40 per month fee. So I can take this 40, plug it in for that T over there in the first equation. So I got 40M equals 50 plus 30M. Let's get the M by itself. So months, in 5 months, they'll both be the same. Now they want to know how much too. So I'm just going to take this second equation here and plug it into that one. And we'll say T equals 40 times 5. And that should be $200. So now we have to answer the question. The cost will be the same. In 5 months. That cost will be $200. Now they said if you plan to cancel in a year, which I know that 1 year is the same as 12 months, which is cheaper provider, and explain. Now sometimes you can explain by showing your work. And so when they ask which is the cheaper, you also should state how much cheaper it is. We're trying to make some financial decisions here. So option 1, I'm just going to put OP1. And they said T, our total is 50 plus $30 a month. And if we're going to go for 12 months, let's do that math real quick. 50 or 30 times 12 plus 50. So option 1, I got $410. Option 2. So on option 2, I'm just going to use the equation. This is how I'm going to do my explaining because they said explain. So option 2, my total was 40 times 12. And that is 480 is what my calculator is saying. So looking at these two, looks like option 1 is $70 cheaper if I go for the whole year. And so we need to answer the question now. Is $70 cheaper for 12 months? So you're kind of answering the question intelligently. If it's only worth like maybe $1 or something, somebody might say, well, option 2 is just around the corner, so it's not worth my time to go all the way across town. So there you go. You have one now for a try it. As always, I got the answer on the next page, so pause your video, give this problem a shot, and let's see how you do. All right, I'm hoping you did okay on this one. I got in 10 months, the cost will be the same amount of $860 for the first letter A. And the first option would be $40 cheaper in this case, so it's option 1 and 1 again. All right. So there again, my explaining is through my work there, option A and option B, on how to do things. Okay. All right. So you have a couple problems today. There's a whole lot of computation. So I hope you have a calculator. There's a couple on here that are fractions. And so you're going to have common denominators because a third is a repeating decimal. So don't skip the fraction ones. Let's get used to them. Okay. 12 is going to be the common denominator. So, or you can use that strategy of getting rid of fractions. You want to talk about that one more time? Let's get rid of fractions here. Let's make this equation fraction free. All right. So do you agree that 6 is going to be my common denominator for 2 and 3? So what we're going to do is we're going to write a 6 up here on all these, and this is really 5 over 1. And here's how we get rid of fractions. 2 goes into 6 3 times. 3 times 1 is 3x. 3 goes into 6 2 times. 2 times 1 is 2. 1 goes into 6 6 times, and 6 times 5 is 30. My fraction is gone. If you want to get rid of this 1/4, you could use it as a 0.25, or we could just, let's make this whole thing 4 times bigger. So 4 goes into 4 1 time, 1 times that, so that's just x plus 4y equals 40. Now I don't have a fraction anymore. Okay, good strategy to know. I almost got the x by itself on this one, so I'd get rid of that 4y. All right, and I think you got 1, maybe 2 word problems. All right, good luck. Today on the answer sheet, when you put it into Google Forms, all you're going to do is put in the coordinate. Make sure you use parentheses. I'm probably preaching to the wrong crowd. Still, I'm seeing quite a few people that aren't watching the video. Maybe they're watching other videos and learning how to do the math. Let's hope so. All right, have a good day. We'll see you tomorrow.